In this video, we'll briefly talk about databases, specifically how to work with SQL Server 2005 Express Edition databases. But before we run, we need to walk. So we'll start out by talking about databases, what they are, why to use them, and how they're structured. And then I'll demonstrate how to create and use a SQL Server 2005 Express Edition database from within Visual Basic. And finally, I'll demonstrate how to modify data that's stored in a SQL Server 2005 database as well. So let's start small. What is a database? Well, simply put, it's a structured repository for data. You save information in a database, you read the information from the database, you update the information, and sometimes you need to delete the information. The information is organized so it can be retrieved easily, can be sorted, can be grouped, can be related to other data, and thereby can be used to analyze information in a countless number of ways. So let's say you have a business and you want to keep track of customers. You could store customer names in a simple text file using Notepad. But the problem is that after a while there's so many names that it becomes unmanageable, and you have to scroll through this long file to find the name of the customer that you need to follow up with. So you decide to store the names of your customers in an Excel spreadsheet instead, which works for a while, but what happens when you want to view all the purchases in the month of April for your top 10 customers? Well, I suppose that's possible in Excel, but it's not as easy as using a relational database management system, or RDBMS, like SQL Server. And this is just the tip of the iceberg in terms of benefits in using a real database over a text file or an Excel spreadsheet. It's probably the most easy way to understand it, though. Now, up to now, SQL Server was considered a high-end database server used in large companies to enable the management and the retrieval of relational database data. In SQL Server 2005 Express Edition, however, you can harness the power in the most simple applications that you can dream up. Now, I use the term RDBMS, or Relational Database Management System. This is actually a philosophy or an approach to designing a database that's analogous in some ways to writing object-oriented code, although it's very different. Different techniques, different goals, etc. But in relational database theory, you organize your data into tables that are related with other tables and so on. So you might dedicate a table for customer names and another table for order information. Now, you could just create one table that contains both customer and order information, but then you run the possibility of having redundant information when you have a customer that ordered twice. And then there's also the issue of data integrity. What if the customer called himself Bob on the first order and Robert on the second order? Or a better example might be if the customer moved. It would be difficult to determine that both orders were in fact from the same customer. So it makes sense to manage this information in separate tables. Now, there's really a lot of rules that were created back in the 1970s and the 1980s by the creator of relational database theory, and those rules are called normalization. And we're not going to take the time to go over the rules, but be aware that I've really just skimmed over this idea, and you can find out a lot more on your own. In most cases, you can normalize a database with just a little common sense. Once you see it done a few times, it's going to make a lot more sense to you. You'll pretty much have the idea under your belt. So let's dig deeper into database objects. First of all, please take the time to read the document that I've supplied that accompanies these videos, because it's going to have some additional information that will supplement what I say here. So we're going to start with the concept of a table. And a table is the foundational database object. A table consists of columns and rows, or rather records. A single column in a single row is often referred to as a field of data. The columns define the type of data that will be stored in the table, and the rows or records are the actual data. So we might have a simple customer table with the following columns: first name, last name, address, state, zip, credit limit, customer since, and so on. And we've probably left out a number of fields that should belong in there as well, but I think you get the idea. In order to maintain data integrity, we need to define more information about each column, such as the type of data that's going to be stored in that column. And in some cases, like for example string data, we're going to have to define the maximum number of characters in the string. We'll also need to define whether or not a particular record can be saved if it contains fields of information with null data. Now, what is data integrity? It actually takes several forms, and it's one of the major things that a relational database system will help you maintain. For example, we may not want to allow somebody to add data to our database that sets our credit limit field to $2,000, all spelled out, TWO, THOUSAND, and so on. What we want is a numeric number that represents currency, so we'll probably use a currency data type, and that'll exclude the possibility that somebody will spell out $2,000. Because we can't add the words $2,000 to a currency value of 1,500 or so on. Now the same is true for the customer since field. We can see that we've defined that as a date data type, and so it should only allow date values, and state, for example, should only allow 2 characters. For example, TX for Texas, CA for California, and so on. Now moving on, we may want to allow a record to be saved to the database if that record doesn't include an address. But we may not want to allow a record that doesn't have a name, where the first name and the last name is missing, for example. That wouldn't make a whole lot of sense. So what we could do is define certain fields like address, state, and zip to be nullable fields. These fields do not have to be supplied in order for the record of data to be saved successfully into the database. However, if first name or last name is missing, the database can reject the attempt by the application or the user or whatever the case might be to try and save data into the database. This is in an effort, again, to maintain the integrity of the data in the database. Data integrity is, simply put, just an attempt to make sure that the data that's in the database is correct and meaningful and useful for the purpose of any applications that might use the data. Now finally, we're going to want to add one more column, and we're going to use this column to uniquely identify this row of data. We're going to call the column Customer ID. And this type of column is referred to as a key, or better yet, a primary key. Now why do we need a key? A key is a way to differentiate 2 customers, or rather 2 records, that have the same name, for example. Now, while you may have 2 records with the exact same information, that has the same name, same address, and so on, one field of data should be used to differentiate the rows. And typically, you're going to want to use a numeric field for this information. And so we can set a special property of that column called identity, which will automatically number each record of data as it's added to the database, and we'll use that automatically numbered field of information for each record of data as its primary key, as what differentiates it from the other records in the database. The primary key is also used in order to relate 2 tables together. Now, in addition to our customer table, let's define an order table. So you can see here that I've defined 4 columns: order ID, order date, order amount, and payment type. Now again, I probably left out some important information, so for our purposes we're just wanting to investigate how this all works. But in a more real-life scenario, we may need to include some more information here. Most importantly, we left out the information that allows us to determine who actually created this order. Now this is a real problem that we're going to need to address now. We need to relate a row from this table back to a row in our customer table, and the way we do this is with a foreign key. So here we're going to add one more column of information called customer ID. And now it just so happens that we named this field the same thing that we named it in the customer table, but we didn't need to. We could have named it anything we wanted to name it. However, to make things easier to understand, we wanted to name them exactly the same. Now, by creating an order record and including the customer ID, we can easily tie back any order to the customer that created the order. Also, we can easily tie back all of the orders ever created by this customer, tally how much the customer has spent with our company, and a lot more. Okay, so just to recap, we have a primary key in the customer table called customer ID, and we have another key, another field in the order table that we've called a foreign key in the order table, and so now it's possible to relate these two tables together. The primary key and the foreign key can be related together, thus making a relationship between these two tables. But from a database perspective, we still have a problem. If I were to delete a customer in the customer table, all of the associated orders that were placed by that customer would be what's called orphaned, which means that we'll never be able to tell who ordered those items. That would be a huge problem, so what we need to do is create a special object in the database called a constraint, specifically what's called a foreign key constraint between the order table and the customer table. And when we do this, nobody would be able to delete a customer before deleting all of the associated orders first. The database just won't allow it because doing so would violate the integrity of the data in the database. You cannot have orphaned rows. So that was a pretty quick overview, and I hope you can see now at least some of the concepts of what a relational database is. Relational databases help keep data structured and therefore easily managed. They reduce redundant data by splitting up duplicate data into its own tables, and it helps to maintain the integrity of the data, among other things. So let's now transfer this knowledge of databases into creating a SQL Server 2005 database. And then we're going to add objects like tables and fields and relations to the database, and then finally we'll add some data to it. Please note that portions of this video were recorded using the C# equivalent to Visual Basic 2005 Express Edition. The functionality that I'm going to demonstrate is exactly the same between the two versions, so this shouldn't impact your ability to understand these concepts. Okay, so I've taken the liberty of creating a new project called Lesson8, and I just want you to know that there's actually several different ways that you can go about creating a new SQL Server Express 2005 database, but I'm going to use a more project-based approach for this example. So with my project open, I'm going to right-click on my project and select Add, New Item, and from the Install Templates section, I'm going to select a SQL database, and then I'm going to change the name of the database to Lesson8.mdf and select Add. Now, by default, it's going to pop open this data source configuration wizard. Let's not worry about this for right now. I'm just going to select the Cancel button. And then I'm going to double-click this file within the Solution Explorer so that I can open up the Database Explorer with my database already loaded in. Now, you can see here that there's some files underneath the lesson08.mdf file that's loaded under the Data Connections node. And what we want to concentrate on are tables. And by default, there are going to be no tables in the database. But what I want to do is right-click and select Add New Table. Let's reposition a few things here so we can see the main area a little bit better. Now we have a designer surface where we can create a new table. And we're going to kind of be forward-looking and create two tables that will be eventually used within our RSS Reader application.